This is AP Calculus Self-Check 6.3 Solutions. All right, let's dive right in. So we have this differential equation, dy dx is equal to x, y cubed, and a bunch of other stuff that we don't need to worry about for part A. We need to write the equation of the line tangent. Line tangent, you immediately want to think of y minus the y coordinate is equal to the slope times x, slope times, in parentheses, x minus the x coordinate, end parentheses. All right, what does it give us? It gives us an x coordinate and it gives us a y coordinate. It also told us the x coordinate again here. So we already know these things. We already know that the x coordinate is 1. We already know that the y coordinate is 2. We just need to find slope. The way that we find slope, it says slope is equal to this equation. All we need to do is plug into x and y, and we have slope, we have our equation. So let's do this. So we have, we can say that this is dy dx. You can say f prime 2. It doesn't really matter in this case. This is equal to x y cubed. I'm just setting it up again, and I'm going to evaluate x equals 1 and y is equal to 2. All right, so when I do that, my dy dx, that's going to equal, my x is 1, my y is 2 cubed, and that is going to be 2 cubed is 8 times 1 is 8. We have our slope of 8. We can fill that in, and we have our answer. So it's y minus 2 is equal to 8 times x minus 1. There it is. And you can leave it in this form. You'll still get the points. You can add the 2 to the other side, distribute the 8. It's all the same thing. I would recommend not doing that. Leave it like this. You might make an error. And then the question is, how do you score yourself? So if you got 8, if you somehow found that f prime or dy dx is equal to 8, plus 1 if you're able to find the slope, 8. And then another plus 1 if you're able to get the entire equation correct. On to part B. So we're using the tangent equation, this guy that we got from our last part, to find an approximation at 1.1. So we're plugging in 1.1 in here and finding what that gives us. So let's do that. When we do that, we have y minus 2 is equal to 8 times 1.1 minus 1. It's best to leave it in this form because otherwise it becomes really hard if it's in y form when you distribute the 8. So when I do that, 1.1 minus 1 is 0.1. So 0.1, maybe I should write this out. 0.1. All of that is being multiplied by 8, and that is equal to y. Instead of writing minus 2, I'm going to add that right now, plus 2. So that means our y is equal to 8 times 0.1 is 0.8 plus 2, and therefore our y, and since this is an approximation, you should really be writing approximately equal to 2.8. All right, so that's the first part, and if you got this, that's a 1 point right there, plus 1 point if you're able to get 2.8 for your approximation. I think if you write y equals, you'll still get the point. All right, the second part of this question is, given that f of x is greater than 0 between these 2 points, is the approximation greater or less than? How do we figure that out? So this is kind of a throwback to last unit, I think last unit, maybe 2 units ago. I forget when we did this, but you have to find the second derivative. You kind of remember when we had a graph like this, say you had a line like that, a point here. If I had some second derivative, the concavity was positive. Let me try doing this better. Concavity was positive. You note that positive concavity, so f double prime greater than 0, means that it's going to be an under approximation because I'm using the line to approximate, but the second derivative is positive, therefore it's more likely to be up here. So we guessed here, but it's actually up here, therefore it's an under approximation. So when the second derivative is positive, this means under approximation. And vice versa is true too. F double prime less than 0, that's going to be over approximation. And that works if it's a positive or negative slope. That it doesn't matter. You're just looking for f double prime here, and that'll tell us if it's an under or over approximation. So, is it greater or less than? Is it over and under approximation? And explain our reasoning. So, let's just find the second derivative. So, we need to go back to this part. We have our second derivative, so it's right there. So, it's y cubed, and maybe I can just screenshot this and bring it into our next slide. So, we have our second derivative here, and we know We only care whether or not this second derivative is positive or negative. So we don't really need to sub in values here. We know that anything squared is going to be positive. So this whole thing here is going to be a positive. We only really need to know, is this y cubed going to be positive? And it tells us that. It says, look, y is really f of x. Y is always greater than 0 for that interval. So you're going to say, well, because y is greater than 0 for that interval, for 1 is less than x, which is less than 1.1, between 1 and 1, we know that this thing is interval. So we know that you can say d squared y, you can rewrite this all, or you can equivalently say y double prime. They'll know what that means too. Y double prime is greater than 0, therefore, and you don't need to explain this, they just expect you to have that memorized. If this is greater than 0, that means that it's going to be an under approximation. So therefore, how are we going to say this? Therefore, the approximation at 1.1, or maybe you should say, you can just say at 1.1, but I'm going to say at x equals 1.1 is and what do we say? This is greater than, therefore it's an under approximation. Under approximation. Is there a hyphen here? I'm not exactly sure. Under approximation. All right, so that is the answer to this second part. So you can give yourself 1 point only if you do two things. You need to know, you have to state this thing. So this thing is kind of key. You have to say, we know that y is greater than 0. I know they gave it to you, but you have to have y greater than 0, and therefore you have to have, so I guess there's technically three parts. You have to have one part here. You have to have this second part here, that y double prime is greater than 0, and then the third part, the conclusion, needs to be correct, that it is an under approximation. Once all three of those are correct, then you get +1. And finally, on to our final part, our part C. So we need to find the particular solution. So this means we're going through steps 1 through 3, and if you have somehow memorized step 4 because you are amazing, then you can do step 4 as well, where you actually isolate. So we are dealing with these initial conditions. What is our differential equation? There it is. It's from our first part. So let's go ahead and do this. So we need a fraction equal to a fraction, and once we have that, we cross multiply. So I'm going to have a 1 dy, I like to keep the y's on the left, is equal to, my y cubed dx. Look, I have a y on the right and a y on the left. I need to make sure that all the y's are on the left. So I divide both sides by y cubed, and I'm left with 1 divided by y cubed dy is equal to x dx. Perfect. That was step 1. That was step 1. Step 1 was to separate. The variables have been separated. If you don't do this, you get 0 points. All right, number 2. Step 2 is to integrate. Integrate. So when I integrate, I'm going to do the integral of, and this is going to be y cubed. I don't like fractions. None of calculus students like fractions, generally speaking. It's going to be y to the negative 3 dy is equal to the integral of x dx. Okay, now time to take the antiderivative. Y to the negative 3, I'm going to go up the power, y to the negative 2, divide down, all this divided by negative 2. That's going to be equal to, x goes up a power, x squared, divide down, divide by 2, and then don't forget your constant of integration, your plus c. All right, step 2, done. Step 3 is to evaluate. Evaluate. You don't have to write the evaluate, so I'm just writing it for you guys. You know what step 3 is. We know that this is going to be our x, this is going to be our y, therefore when I evaluate, this is going to be, and I'm going to leave it in this form, otherwise I'm going to mess up. Well, I might mess up. I don't want that chance. 2 to the power of negative 2, all of this divided by negative 2 is equal to, and then x is going to be 1 squared, all of this divided by 2, don't forget your constant of integration. All right, and that's all you need to do. I mean, you could do step 4 of isolate. I will show you that if anyone asks, but this is as much as I want us to do. So how many points did we get? We got 1 point for separating. So if you did this, you get 1 point. And if you don't do that, you don't get any points. You only get 1 point here for integrating because both of these sides were pretty straightforward. +1, oops, there we go. And Then for evaluate, oh, don't forget your plus C. Plus C always gives you +1 immediately. And evaluate, if you use these initial conditions, you got another 1 point. There's 1 point missing here, and that's from the isolate step, getting y by itself. And I can show that if you would like, but you do need to ask me for that. But generally speaking, you don't need to do that in order to pass the AP test. You don't even need that to get a 5 on the AP test. All right, that concludes self-check 6.3, and give yourself 10 minutes to do self-check 6.4. I'll see you in the next video.